welcome everyone. This is the coding part, and in this video we'll be talking about the programming paradigm. Basically, this video is about the paradigm, the structure, the pattern, right? Like people use for programming. You might have already worked with a few programming languages, but behind the scene there are lots of programming languages, and every programming language they follow their own model, their own style, right? That refers to a pattern of writing a program. So which basically means you write a program. That program might be easy, a concise and simple one. That's what we prefer, right? And every programming languages, they have their own own style of putting the things. So that could be easy. While some are vague to understand because we are not used to it. The structure might be different, right? So the most common paradigms that we have is the imperative programming paradigm, and the other one is the declarative programming paradigm. So under imperative you have procedural, structured, object-oriented programming, which you simply call that as OOPS, right? And the other one is the declarative programming, functional programming, and the logic programming. So let's first see how do these two imperative and declarative programming, they differ from each other. So basically, if we have to see the core, the deeper meaning behind the imperative and declarative is simply how you do something is what imperative is, and declarative goes for what you do. The first one that we're discussing is that we're saying is the procedural programming. It's an imperative type of programming. It splits functions into procedures, and it's always stepwise. And procedures aren't functions; they don't return value. It just causes a desired effect, right? So the programming languages that follow this this design, or this this structure, this paradigm are Fortran, C, COBOL, are some procedural programming paradigm. So let's see. Okay, so let's take a look at an example of COBOL implementation. So let me quickly type a simple program that does the multiplication, that displays the multiplication table of 5, which I have already set here. Which is already fixed. You could change the number, and as per your choice to display. There's a dash there. Storage section where we'll be storing 77 num1 pick so 99. That's 9 for storing our value. So this is the multiplier, and now there is num2 pick 9 value 5. Here this is our multiplicand, so this is our multiplier, and the above one is multiplicand. So 77 res pick 99. So this is where we will be storing our result. And so let's start. So this is the starting of another section where we'll be writing the loops and all. So perform vari. So b. Let's say this is just a name, right? You can use it any name you like. Writing num1 from 1 by 1 until num1 goes to 0. So all we are doing is we are writing a condition. If the number if the value of b goes to 1, then what we'll display is a message where we'll say execution completed. and that's what we'll do after what we'll close. And here we'll call the above lines. So after multiply num2 by num1 and giving us a result, and we display num2 x. We're just formatting our output, nothing much, equals to, so that would be the result, right? And the strange thing about COBOL is we need to leave a new line for this particular problem in this compiler. So there we have so this is the table, multi-material. Let me inspect the element and remove these two lines so that you can see very clearly. Yeah, so this is pretty much about the COBOL implementation. So we've seen the procedural paradigm. Moving on, let's see the structured programming. So structured programming, it's also an imperative programming. Like, you are quite familiar with different types of structured programming that follows C, Java, Kotlin, Python. Even Python is structured programming. So one of the attracting feature of the structured programming is it improves the code readability. Now you may say, like, the Python, it's the cringy thing is like the indentation error, right? But Java, C, C++, they provide this curly braces, which is kind of comfortable using, right? But I pretty prefer Python. I feel like it's more readable. It optimizes code by using control flows, decision making, if else, right? And it gives so much bunch of instructions. Like, it's not like it's very less like what we just saw, the COBOL. Oh my god, it took me quite some time to understand the code, So yeah, and so for structured programming, I don't have I'm not going to demonstrate an implementation, because you guys are very familiar with these programming languages, so I have not implemented since I don't think that's a thing it would take for you to understand. So moving on, like, with the logical programming, logic, right? So it's a type of declarative programming, and it's based on formal logic. It's very, very straightforward, right? And it's made of facts and clauses rather than instructions. The simple its structure is, you have a question, a machine is there, it inquires the knowledge base, and whatever the result it gets, it returns that as an answer, right? So it's based on formal logic. Behind the scene, it's the truth table that's being actually being implemented, right? So let's see let's see a Prologue implementation of logic, that Prologue, which follows the logical programming paradigm. Okay, so let's see now the Prologue implementation. So it's quite easy. I mean, we'll just see a number. I mean, here we will compare, okay, two numbers. Right, if the number is greater, what we'll do is we'll simply write x is greater, right? Is greater is smaller number, so we just put a full stop there. So simply let me just copy that and paste it here. So if r greater, say if this is just the opposite, let's say x is smaller, and if both are equal, let's say if they are equal, equal, then both are equal. Let's now pass some parameters or value to this function that we've just written in Prologue. So let's see if we get the error. Okay, so 5 is smaller. So let's again give another input. Let's say 15, 10, and let's quickly run that. Okay, so multiple queries, it doesn't accept. So let me just delete this out and run that again. Okay, 15 is greater, right? So let me pass two in equal number. We passed it as 10. Okay, so both are equal. We just saw the Prologue implementation. Let's move on to another paradigm, that is the object-oriented paradigm. So OOPS is another object paradigm. It's an imperative programming language, which means it's based on how you do something, right? So it provides code modularity, and it associates real-world business problems into code. It offers robust security features, and some examples that that encompasses this object-oriented programming is Python, Ruby, and Java is not purely, because it's more like the structure, right? So another one that we have is the functional programming. This is a type of declarative programming. It's written in, it uses functions everywhere, right? It uses functions. It uses the arguments, and arguments are passed to the function, and it's also written, and those functions are also written value. So it uses a chain of functions, you see. So, and all those functions returns the value to its previous function. So that's what functional programming is. Let us quickly see Clojure's implementation, how it implements this functional programming. All right. So let me quickly open an online compiler. So this is mycompiler.io. So let's see. Let us in this program also I'm trying to display the multiplication table, a simple multiplication table. So x11. So why I'm using x11 is because I want to display the product of numbers until 10, which begins from 0, right? Okay, so if x times I'm just formatting the output, alright, nothing much here. So I'm trying to pass the value format percentage 3D, and let me close that, and asterisk. You might be wondering what kind of syntax this is, right? So, but you need not worry, because we are not. But functional programming is really awesome. Yeah. So let me just quickly run this. I hope it doesn't give me any error. Oh yeah, there you have, right? So okay, so we're getting one extra inverted comma there. So let me not use this, but so sorry. So let me use a double quote there. Let's check this. Let's run that again. Okay, so it's gone, right? So yeah, 3 times 0. Yeah. Okay, actually, maybe I should place it this way. Right? If I do this, then possibly I will get it in proper format right now. Display output. Okay, fine. So this is the implementation of functional programming. So these are the examples that I just implemented. You can just take a quick look, right? Prologue, all this thing. So now Now the question is, which is better paradigm? Which paradigm do I need to follow? So to be honest, like, it totally depends upon the problem in front of you. Okay, like your objective, what do you want to try to, what are you trying to achieve, right? So it's not always that a particular paradigm is the fastest, or it's beautiful, or it's you're comfortable with whichever paradigm you're comfortable with. And if you think you can achieve your task or your goal, then that paradigm is the best choice for you, right? There's no any particular, and it highly depends on which paradigm your team is familiar with. And also you must see the benchmarks to know which paradigm is better for your development. And it's also the matter of how efficient that paradigm is for you, right? I hope this gives you some insight about what different programming paradigms are. So in coming days, I'll be posting about Python and lots of interesting things, right? See you in the next video. Thank you.